Hello all. In this session, we will study about the principles, basic principles in the mechanics to solve the problem. In the last session and in the last PPT, I have explained about the definition of mechanics. In that, to solve the problem, we need three important principles. That is, principles of forces, principle of physical independence of forces, principle of superposition of forces, principle of transmissibility of forces. We have these three important principles of forces. First, I will explain about principle of physical independence of force. It states that if a number of forces are simultaneously acting on a particle, then the resultant of these forces will have the same effect as produced by all the forces, right? So in the figure you can see individual forces, if it is acting individually, the number of force simultaneous particle, then the resultant will be same if all the forces are acting together. Okay, so action of forces on bodies are independent. Action of forces which is acting on the body will be independent, but in other words we can tell action of force on a body is not influenced by the action of any other force of the body. That means the one force action is not depend on the any other force. It is influenced, it is not influenced, it will be acting individually, independently it is acting. So you can just remember this word independence. All the forces acting independently on the body without considering any other forces. Okay, principle of superposition of forces. Okay, so principle of superposition means if the body is under rest, any body, for example, you're in your home, sofa, table, TV, everything, it will be under rest. No forces will be acting, but always the nature forces will be acting on the body. Okay, so the net effect of forces applied in any sequence on a body is given by the algebraic sum of effect of individual forces on the body. Okay, so the net force, the final force which is applied, it will be on a sequence on a body. It is given the algebraic sum of effect of individual forces. Here I have taken a small point and I have distributed all the forces. Law of transmissibility of forces. Okay, so here first I will tell the statement. The law of transmissibility of forces can be proved using the law of superposition. We are just taking the superposition concept to solve the transmissibility. The action of a given system of forces on a rigid body is not changed by adding or subtracting any other system of forces in the equilibrium. So superposition of forces can be defined as, here you can see superposition, this one. Here this definition also you can consider. If the action of a given system of forces on a rigid body is not changed by adding or subtracting any system of forces in equilibrium, you add or subtract that, the system of forces, it will not change. Okay, here you have three figures. You can see figure A, figure B and figure C, right? So in the figure A, the force is acting at A, that's it. And in figure B, you have three forces, 1, 2 and 3. And the figure C, final force is there. Okay, the mechanism is, in the figure A you can see only one force is there. To balance this, at the B we are just introducing two forces. Okay, this is a system of forces concept. So here one force and here two force. In the total three forces, which two are coupled? Which two are acting oppositely? Okay, so this one and this one will be acting oppositely. The remaining forces, this one. So that is showing here. That is the force is F. So this is the transmissibility of forces. That means if the force act, for example, one body, if the force act in the one point, if you're giving one point, the object the body will move in the same line of action which the same force will come out. That is the concept of the transmissibility of forces. That means any body which is giving the force at one point, the body will move in the same line of action giving the same magnitude in the opposite direction. So that is your transmit. That means the force will be going to transfer in the same line. Consider the same thing we need to explain now. Consider the rigid body shown in the figure. It is subjected to a force F at A. Same thing, F at A. Next, the B is another point on the line of action of the forces. B, you have another point in the line of action. Next, from the law of superposition, it is obvious that if two equal and opposite forces of magnitude F are applied at B, that means this one, we are applying two equal and opposite force on the of magnitude F are applied at B along the line of action in the given force F. Refers figure B, as I told. The effect of given force on the body is not altered. That means, for example, if this force is 20 kilonewton, definitely these two forces will be 20 kilonewton only. Okay, the effect of a given force on the body is not altered. That means we are considering same magnitude, that is 20 only. We are considering force F at A and opposite force at B form a system of forces in equilibrium. That means here the force at A and the opposite force at B, these two, okay, we are considering these two. If these two forces are subtracted from the system, the resultant system, this one, the resultant system will be this one. Okay, so finally the conclusion is the whatever the force you are applying from one point, the same force is going to come out from the another point with the same line of action, without changing its effect. It is coming out like this. So this is a concept of law of transmissibility of forces. So law of physical independence, law of superposition, law of transmissibility. So these three principles we are using in the problems. Thank you.